Alright, welcome back to this video. So as I said in the previous video, we're going to start by building our models. Now we've prepared our data is ready to start building our algorithm, our linear regression algorithm. So straight away, let's start by preparing by starting to build our algorithm. Okay, so what we're going to do, remember that in the previous classes I told you when we're doing the introduction to machine learning, we discussed what dependent and independent variable is, right? So just to refresh, right, let me open this one so that you can actually see what I'm going to do over here. Okay, now just to refresh just to refresh on dependent and independent variables. Remember that we use GDP example, right? I hope you remember that, right? And then we say that GDP depends on several factors, right? It could be say maybe the innovations in the country, right? It could be say the technology, so plus say the technology in the country, right? Maybe the technology in the country, maybe also plus maybe the educational system in the country, something like that. So GDP depends on a lot of factors. So if we want to determine the GDP of a country, right, there are several factors that we need to take into consideration. All right, so GDP depends on these factors. So GDP becomes a dependent variable, right? It becomes a dependent variable. Okay, and all these factors, right, which are helping us to make predictions of this GDP becomes independent variables because they don't actually depend on this, right, to help us take the decision, right? This is the one that depends on them. Okay, so these ones becomes independent variable. So in the same case, if we come into our data sets, remember that earlier on, whatever we are doing, right, our target here, right, if you remember, the first thing that we talked about is to build, right, here, right, the first thing that we talked about is to build a linear model, right, or linear regression model to express a relationship, right, that is between the car's mileage, that is the MPG, right, and the other, right, or the rest of the other variables, right. So what we want to do is to find a relationship that is existent between the MPG, right, and all the other columns, right, which includes the horsepower, right, and some other factors. So that's what we actually want to do, right? So let's go down there where we are building our algorithm, right? Let's go all the way down here. All right. So over here, what we want to do is to establish a relationship between this. So MPG is our target over here, right? And all these factors, right? All these other factors are going to help us make a prediction of this MPG, right? So this one here becomes our X. So remember that in the GDP example, right? When we talked about the GDP, right? Where we have several other factors helping us to predict the GDP, we say that this GDP is our Y, and all these, right, are X. So it could be X1, it could be X2, it could be X3, right? Or different variables that are helping us to predict this GDP. Okay, so in the same way, we have this MPG to be our Y, right? We have this to be our Y, and all these could be our X, right? All these are X, right? All these other variables that are helping us to predict this MPG is going to be represented as X. So you can think of this same example over here. MPG will be equal to, say, the cylinder, right? Will be equal to cylinder, right? It will be equal to cylinder over here plus displacement, right? Plus displacement, okay? Plus displacement plus, say, horsepower, right? Plus horsepower plus all the other attributes that you can find all the way to origin, right? All the way to origin underscore Europe. Okay, all the way to an origin underscore Europe. So all these are factors that are going to help us to predict this MPG. So this MPG becomes our dependent variable, whilst all the other variables that we have here becomes our independent variable. So our dependent variable is going to be stored in a variable called Y, just like we are doing over here. Okay, and then you see that in DF we are selecting only the MPG and store it in the variable called Y. Then after that, if we drop this column, right, if we drop the MPG column, you see that whatever is left, right, is these ones, right? This is what is left, right? If we drop the MPG, right? So we're going to drop the MPG, and this one you can ignore it, right? We can ignore dropping the origin equals Europe. You can that step is not actually necessary. You can take away that, right? So the only thing that we need to drop over here is this MPG, okay? And then the rest of the data points we can actually store them. We can store them in this independent variable called x. Okay, that's what we are doing, and we are specifying that whatever we are selecting over here, right, whatever we are dropping, right, is present in the column, right. That's why we're using axis equals 1, right. If you use axis equals 0, you are specifying that whatever you want to drop is present in the index or in the row, right. But in this case, whatever you want to drop, that's the MPG, is present in the column, right. It's present in the column, so we use axis equals 1. So over here, if we use axis equals 0, let's try that one and then see what we are going to get, right. If we use say axis equals 0, right, if we do that, we're going to actually get an error, and see what the error is saying. MPG and origin underscore Europe is not found in axis, right. So it's actually going to look for them over here. It's going to look for them over here in the row or the index over here, right. But it's not going to find it because they are not there, right. However, if we do it if we do 1, right, if we do it as 1, you can see that now everything is working, because it will find the MPG over here, right. To find it in the column. All right, so that's one thing that you need to actually take note of. Okay, now remember that in the previous class we talked about how we talked about training and testing data, right, and then we also talked about how we divide our data set. Okay, so that's exactly what we are doing here. So everything that I discussed with you, everything that we learned in our previous classes, we are going to be needing them. That's why earlier on I introduced you to them, so that you get familiar with them, so that you're not, things will not be new for you when we get here. Okay, so now what we are going to do over here is that now we have what we have done so far is to divide our data into dependent and then independent. Okay, now what we're going to do over here is to split this data that we have, right, to split them into training, right, to split them into training, right, into training data sets or training sets, right, and then testing, right. So that's what we are actually going to do over here, into testing data sets, right. If you remember, in our previous class we learned about training and then testing. Okay, so that's what you're going to do here. So if we pick say the x, right, if we pick the s, now the number of points that we are going to use for training, right, we're going to split it, right. We're going to do this randomly, right, and we're going to store that one, the one that we use for training. We will store it in a variable called string. So all these are variable names that I chose. You could have used any different other name as well, right? But as I said, if you're giving any variable name, make sure that it makes sense to whatever you're doing. Okay, so in the data points in x that are going to be used for training, right, I'll store it in a variable called xtrain. The data points in x that I'm going to use for testing, I will store it in a variable called stest. Okay, and then when you pick the y which contains the MPG, right, the part of the y which I'm going to use for training, I'll store it in a variable called ytrain, and the part of y which I'm going to use for testing, I'll store it in a variable called ytest. All right, now what is going to happen over here? If you see the test size over here, right, you can see that we have 0.30 over here. It means that the amount or the quantity of my data point that I want to use for testing. Okay, so in this case I want 30% of it. I want to use 30% of it for testing. That's why you can see 0.30 over here, right? Then I will use 70% of it, right? I will use 70% of it for training. All right, so what you are going to specify over here is the test size, right? It's test underscore size, right? So you specify, so this could be it could have been say 80 and then 20 here, right? Or it could have been say 75, right? 75 and 25, or it could have been say 60 40, right? So all depends on you, right? If you do it and it's not working well for you, you come back and then you change it. Okay, and all these this it's not that I have 70, not that I have 70%, the specific 70% that I want to select, or specific 30% that I want to select, right? All these are going to be done randomly, right? It's going to be done randomly, and I'm setting a seed here, right? Random state equals 1, so that if I run this code for the first time, it's going to generate random 70% data points, right? Which are going to be used for training, and then 30% of the data points being used for testing. That's the first time. If I run it for the first time, that's what it's going to do. If I run it again, it's going to actually generate another random variables for me, right? I don't want to do that. If I run it for the first time, the random variables that it will generate for me, I want to use the same random variables when I run this code over and over again. Okay, So in order to work my way around of getting different random variables when I run my code over and over again, if I'm setting this random state equals 1, so that anytime I run this code, I'm going to get the same random variables as the first time that I run it. Okay, I'm going to get the same. So this one is just hypothetical value that I put. You can use 2, or you can use 3, or you can use say 10, or I mean any seed that you can set over here. The main reason here is that if you set the seed, it's going to generate random variables for you, and these random variables are going to be the same thing anytime that you run the code. All right, so I hope this part is, the intuition behind this part is clear to you. All right, so we're going to move on to the next step. Okay, so after this one is done, right? After this one is done, the next step is to actually build the algorithm itself. Okay, so this is where this is the most important part, and this is what we've been waiting for, right? This is everything that we need to do. Okay, now if you see this linear regression here, remember that earlier on, right, when we started, in the previous video, right, when we started, we first imported the various libraries that we need, right? And we imported this linear regression, right, which is present in linear models, right, which is present in scikit-learn, right, sklearn over here. Okay, so we've already loaded or imported this, right? So we're going to use that. We're going to use that to actually build the linear regression algorithm that we need. Okay, and don't forget, we are using train test split, right? Before we move on, we used the train test split function here to split this data into the 70-30 ratio that you can see, right? And being able to pack them into S train and S test and Y train and Y test, right? So this is what the train test split will actually help us to do. Okay, now coming back to where we were, right? We actually need to initialize our model, our algorithm, right? We need to actually initialize it, right? So we initialized our linear regression algorithm to a variable. I just chose a variable name called regression model. So over here, we could have maybe just simplified it to say model, right? You could have done that. Okay, so I just name it as regression underscore model, just to be sure that I'm building, or just a variable name, right, that specifies that I'm building a regression model, right? But you could have select any data, any variable name at all, right? You could have used any variable name at all. All right, now this is the most important part that you need to actually take note of, right? You need to actually take note of. After I have initialized my linear regression algorithm, right, what I'm going to do is that I'm going to use that, right? I'm going to use my linear regression model or algorithm to actually learn from this S train and then the Y train. Okay, I'm going to use this regression model to actually learn from this S train and then Y train. Remember that we divided our data set over here into 70-30 ratio, where we're going to use the 70, right? We're going to use the 70 for training and then 30 for testing, right? So over here, our algorithm is actually going to learn from these X train, right, and then the Y train, right? So in order for it to be able to learn, right, so that's why we're calling this function fit. Right, so this is where the learning starts. So you can think of this as our linear regression learning from S train and then the Y train, right? So we're going to say that regression model dot fit, right? So it's more like regression model dot learn from what? Learn from the training data. Okay, so that's basically the intuition behind this. So regression model dot learn or dot fit, right? So you can let me do this. So the regression model dot fit, right? So dot fit is more like dot learn, right? Learn from the X train and then learn from the Y train. Okay, so this is all that we need. So if we run that right now, this is done. The model is built. Our model has now learned from our training and then testing, right? So this is the only thing that we need over here. This one is the one that has learned from our training data. This is our model, and this is what we need. Okay, this is all that we are looking for in this protocols. Okay, this is all that we are looking for to do. Okay. Now we can check the coefficients. Remember that when we went to the whiteboard, right, we talked about the linear regression line, right, or the regression line, right? We talked about something where we saw that y equals y equals mx, right, plus c, right? And if you have several x, right, in this case we have several x, right? We have the horsepower, we have the acceleration, right? We have a lot of we have the cylinder, so several x that we can talk about. So in this case, we're going to have, say, y equals m1 x1 plus, say, m2, right, x2 plus, say, m3, right, x3, so all the way to the last one, right, all the way to, say, now remember that the last attribute that we have over there is origin underscore Europe, right? So all the way to, so maybe x9, right? I think it's x9, so we're going to have m9 x9, right, all the way to that part, and then plus our constant c. Okay, so we'll be having several x in there. Okay, we'll be having several x in there. So in order for us to get this m, right, which is the coefficients, right, right, we use the coef underscore over here to actually get the coefficients. Okay, so we're going to get the coefficients of the various columns that we have over here. So we're going to have a coefficients of cylinder, coefficients of displacement, coefficients of horsepower, weight, acceleration, all the way to the last one. Okay, all the way to the last one. So let's see the output of that, right? Let's see the output of that when we do that. Okay, so these are some of the coefficients that we have over here, right? These are some of the coefficients that we have over here. So you can think of it this way, right? You can think of these coefficients this way. Now let me bring my pen. You can think of these coefficients this way. So if we pick, say, MPG, right? If we pick MPG, right, there are several factors that are helping us to actually build this MPG. So let me do this, right? So that will be a bit clear to you. I'm actually going to bring our df over here, right? df.head. I'm going to do it like that. Oh, df.head, right? Supposed to be in lowercase. Okay, now this is what we have over there, right? This is what we have over here. Now you can think of these coefficients in this way, right? We have our MPG. This is our MPG is the target, right? That's what we want to predict, right? That's our dependent variable. So you can think of MPG in this way, right? Now if we pick cylinder, right, we can cylinder, the coefficient of cylinder over here is this, which is negative 0.39. So I'm just going to choose that negative 0.39 cylinder, right? So depending on the cylinder that you'll be having, right? Cylinder plus, so the next one is this. The next one is this, which is a coefficient for displacement, right? So we have 0.02, right? 0.02 or 0.03 if we want to take it to 2 decimal places, right? That's displacement. Okay, and then the next one is minus, right? So minus 0.021, right? 0.021 of horsepower. So I'm just represented with HP, right? And then the next one is also minus, so minus 0.007, right? 0.007 weight, right? So we can do this all the way, right? You can do this all the way to the last one. So the last one here is minus 0. That's this one, minus 0.60, right, of origin, right? Origin underscore Europe. Okay, so what it's actually saying is that if we change this, right, if we have the value for cylinder, right, whatever value that we have, right, we actually going to multiply that value with this, right, whatever value that we have here, we multiply with this, whatever value that we have here, we multiply it with this, in order for us to determine this. So if we change if we change this cylinder by negative 0.39, right, what will be the change in MPG, right? If we have a change of 0.03 of displacement, what will be the change of MPG, right? So that's what basically these coefficients are trying to help us to do, right? So if, for example, if you remember when we did X over here, when we did this in the linear regression class, where we were having something like this, where when x equals 1, y equals 1, when x equals 2, y equals 2, when x equals 3, y equals 3, right? So we're able to plot this kind of point, and then we're able to plot this kind of point. So we're saying that for 1 unit change in x, right, x, y also change by the same unit. Okay, so the same way the coefficient here is also showing the same thing. So instead of 1 unit change, we have 0.03 unit change in displacement, right? So in this case, we want to we want to determine the change in MPG, right, given 0.03 change in displacement, right? We want to determine the change in MPG given negative 0.021 change in HP, right? The same thing, that's the same concept that we learned in the whiteboard, right? The same thing that we are applying over here. Okay, so we can use this coef underscore to actually get all the coefficients over here. Okay. Now let's progress to this. Sorry, let's progress to this part and then see what we can actually get. Okay, so over here I'm actually just specifying just like what I showed you, right? That this one is for cylinder, this one is for displacement, this one is for horsepower, right? So the same thing that I'm doing here, just that in this case I'm just trying to print out the column name and then the coefficient at the same time, right? That's the only difference that you can actually find. I'm just looping through the column, right? The column name, so that I'll be able to print out the column names and their respective coefficients, right? The column names and their respective coefficients. So basically that's the only difference that you can find between this and that. This one I just got the coefficients, right? But in this case I'm printing the column names together with their coefficients. Okay, so that's just the only difference that you can actually get from this one. Okay, so let's actually progress from here and then see what we can do for the next part. Now remember that whatever we do, right, if we let me open this output so that you can actually see, right? So let me get rid of that. Now remember that in our equation, in our equation of a line, right, in our equation of a line we talked about y. Okay, let me get rid of that. We talked about y equals mx plus c, right? We talked about that. Now we've been able to identify these coefficients, right? We've been able to identify all these coefficients for all the different x. So for m1, x1 to all the way up to mn, right? Up to n to x, also to xn, right? All the way to the last one. We've been able to identify that. What about the y-intercept over here, right? So in order for us to get the y-intercept, right, we have what is called the intercept underscore, right? We have what is called the intercept underscore. So if we do that, if we use the intercept underscore, just like we're using the coefficient underscore, right? If we do that, we can see that we have the intercept to be this, right? We have the intercept to be that. So after everything, after we are doing our MPG, right, equals the first one, which is negative 0.39, right, of cylinder, right, plus 0.28 of displacement, okay, plus also all the way to the last one, right? Then finally we will add in this circumstance we're supposed to add, but remember that our intercept here is negative, right? So we cut the x-axis at the negative negative quadrant, so you can see that in this case we're going to have minus 18, right, 18.28 over here. Okay, so this becomes the equation of our linear regression, right? So that becomes the linear regression equation that we've been able to establish over here. So this is what earlier on we referred to as the mathematical model that we actually built, right? So if you remember in the definition, right, in the definition of what machine learning is, when we started with the introduction, we talked about mathematical model, right? That machine learning is about establishing a mathematical model, right? Building a mathematical model which is going to establish a relationship between several variables. Okay, so now you see that we've been able to establish a we've been able to build a mathematical model which is establishing a relationship between MPG and other variables. Okay, so that's what basically the algorithm is, right? Basically that's what it is, establishing a relationship between some target variable and the other variables. That is in case of a supervised machine learning. Okay. do. Now let's check the score of this model that we have built, right? So we can use the score function to actually check the score. Now what I'm doing here is that I'm checking the score of this model, right? How well this model is performing, right? That's the next thing that we need to concern ourselves with, right? I mean, how well this model is doing. So if I check the score, right, I'm checking the score. Remember that I'm putting here S train and then Y train, right? So I'm checking the score on the training data, right? And then I'll also check it on the testing data. So if I check it on the training data, right, remember I told you about the concept of underfitting and then overfitting, right? So we're going to see that concept over here. Okay, that's why earlier on I'm checking it on the training data to see how well my model is actually doing on the data that I've already fed to it. Okay, so if I do that, you see that we have around 81% over here. Not that bad. Okay, so let's see if we check it on the test data, right? So this is the data. If we take the training data, right, this is the data that it has actually learned from. Okay, let me actually output this, right? Now this is the data that is just, let me bring my pen. The training data, right, is the data that a model has already learned from. Okay, so think of this as maybe some lecture notes that you have already learned from. So if you meet these exams anywhere, you're actually going to perform better because you've already learned from it. Okay, and this test data, right, this test data that I reserved, this is containing the 30% that we talked about, and this contains the 70% that we used to build the algorithm. Okay, so this is the one that our model has not seen before. This is the one that our model has not learned from it. All right, so now if we check the score for that, right, if you see how well it's been able to being able to identify the various data points in that, right, you can see that it is actually doing 84%, which is quite good. All right, which is quite good. And by the way, the data point that our model has not seen before, right, some people also refer to it as outsample, right? So if you see any outsample, it's just the same thing as test data, right? It's just the same thing as test data. Okay, so now let's progress from here. Now that we've been able to identify how well our model is doing, right? We've been able to identify that. Now this is our test data, right? This is our test data. This is the one that we reserved for testing. Remember that these things were selected randomly. So if you see the index over here, you can see 174. We picked 174. We picked 399. We picked 250. We picked 274. So we picked 171. So these were randomly. You see that 39 is here, right? So these were randomly picked, right? These are the ones that we've been able to fed into this to actually determine the score over here. All right, this is what we've been able to put over there to determine the score. Now we can actually do a prediction, right? We can predict. Now don't forget that whatever we are doing over here is to be able to predict the MPG, right? The MPG is our target. So if a new feature comes in, if we have a new car with different features like the cylinder of the car, if we have the displacement of the car, if we have the horsepower of the car, right, so we will be able to predict the MPG of the car. That's what we are actually trying to do, right? If we have a new car, right, so let's say we have a new car coming in, right? So these are cars that we have already, and these are the features that they have. Okay, now if we have a new car coming in, and this new car brings their own number of cylinders, right? They come with their displacement, they come with their horsepower, they come with their acceleration, they come with their model year, they come with their origin, right? Whether it's in America, right? If we have these data points, right? Depending on where the car is actually coming from, right? Depending on where the car is coming from. So if we have a new car with these features, right, we will be able to predict the MPG of that car. Okay, that's what we want to do, right? So we have this algorithm has already learned from several cars, right? Algorithm has learned from several cars, and we want to predict new car that will come, right? We want to predict the MPG of a new car that will come. That's basically what we want to do. So this model, right? This model that you can see over here, right? This model that you can see over here has learned from all these data points. I've learned from several cars, right? Has learned from different cars. Okay, it has learned from different cars over here. Now, if a new car comes in with another feature, right? If a new car comes in with a feature, we will be able to predict that, and that's what we are actually going to do, right? That's what the prediction over here is actually doing. Okay, so if we pick our S test, right? S test is consisting of several cars, right? Consisting of several cars. We could have picked just one car over here, right? So each of the row, think of each of the row over here as representing a certain car. Okay, so this one represents one car, this one represents a certain car with different features, right? With all these features. So if you pick this one, you can think of this as a particular car with all these features. Okay, so we can predict the MPG for this car. Okay, now you see that this car has come with these features, right? It's not having MPG column. Don't forget, we don't have MPG column here because we did not add MPG column to the test, right? The test is supposed to come with no MPG, so that we'll be able to, based on these features, to predict the MPG. Okay, now if we see this, right, if we do that, we can see that we are able to predict the MPG, right? We are able to predict the MPG for the first one. We're using the predict function. The MPG for the first one to be 20, right? 20.91, right? Remember, if you see the MPG column, right? Let's go up a little bit, right? The MPG column is something around 18 point, 15 points, something like that. Okay, so these are MPG for these data points or these cars that we have. Okay, so for a new car coming in, right? For a new car coming in, right? If you pick the first one, this is a new car having 6 cylinders. Displacement is 171, horsepower is 97, weight is 2,984, acceleration is 14.1, model year is 75, origin is from America. Okay, so if you pick that, you can see that we have the MPG of that is 20. So with all these features, right, we can predict that its MPG will be 20.9. Okay, so that's basically what we want to do. That's basically what we want to do. We want to actually be able to build this model, right? We want to be able to build this model. This is the only thing that we are interested in, so that when a new car comes in, right, if we have a new car with its own features, right, with its own features ranging from cylinder all the way to the origin of the car, right, we'll be able to fit it into this model, and then we'll be able to predict its MPG. Okay, we'll be able to predict its MPG, and that's exactly what we are doing over here. And we see that the first one we've been able to predict its MPG to be this. Okay. So our model is actually doing good, right? Your model is actually doing good. And if you have a model, right, if you have a model that is actually doing better, remember that I told you about this regression line, right? So this regression, you can think of this regression line as what we can actually use to, this becomes say your model, right? This becomes your model that you can actually base on that to make predictions, right? So we want a model that can capture most of the data points, right? That can capture most of the data points. The higher your accuracy, right? So if you have around say 80, right? 80, so 80, 90, something like that. Okay, you can see that most of the points will lie on the regression line. But if you have your accuracy to be low, maybe something like 60 or maybe 70, something like that, your accuracy, your model is actually, the data points is going to lie a little bit further away from this, right? It's going to lie a little bit further away from your model line or your regression line. Okay, so basically that is what we have over here, right? That's what we have over here. Okay, now if you see this one, right, if you build the algorithm, right, if we build the algorithm, one thing you need to know is that for every algorithm that we build, right, there's a measure that we use to measure in the error that the algorithm is doing, right? The error that the algorithm is doing. So for linear regression, right, we have what is called the root mean square, right? We have what is called the root mean square error, right? We use that one, right, to actually measure the error that is actually doing, right? So if we pick this data point, right, we see that this data point, what is the distance between this data point and the regression line, right? If we pick any data point here, we measure the distance between that, right, between the data point and then the regression line. That is what is actually going to happen, right? So what is actually happening is that initially we have our MPG over there, right? We have our MPG and we represent our MPG by say Y, okay? Then later on we made some predictions, right? We made some predictions, so we can represent that prediction as Y hat. Okay, now if we find the difference, let me actually write this thing here, right? So what I'm saying is that we have our MPG, right? If we take our example, we have our MPG already, okay? And then our model learned from several MPG, right? This MPG is represented as Y, okay? This MPG is represented as Y. Remember that we say that MPG, right, equals several factors like cylinders plus horsepower plus, so MPG here depends on these. MPG here depends on this, okay? So MPG here is Y, right? It's Y, which depends on several X, okay? So now we also made some predictions. So that prediction, we represent that prediction as Y hat, okay? Now if we see that, let's say the original MPG was say, 18, right? The original MPG was 18 here, and then when we did the prediction, we got say 21, right? We got say 21, right? I'm just using an example. Now what we can do over here is to find the difference, right? To find the difference, that is Y minus Y hat, right? Y minus Y hat. That will be the difference between the original and then the predicted, right? So all right, so this is just, this is just one of them. So maybe we could have maybe say 30 over here, right? And then we predicted this one to be say 25, and then maybe we could have say 19 here. We predicted this to be say 25 or 27, right? Something like that. Okay, so we'll be having several MPG and then several predictions that we also did. Okay, several predictions that we did. Now if we find the difference for all these, right? If we find the difference for all this, what we do is that we sum everything up, right? We sum everything up. So we sum all the difference between Y and then Y hat. Okay, then we square it. And divided it by the number of points that we have in there, right? The number of points that we have in there. So this becomes what I refer to as the mean square error, right? So this is how we measure the error, right? This is how we measure the error when we build the linear regression. We use the mean square error to actually measure the error. Now, in order for us to, if we do this, right, you might end up in a different unit as compared to the original unit, right? In order for us to get into the original unit, we use what is called the root mean square error. Okay, so we find the root of this, right? We find the root of that. Okay, so this is the measure of error for linear regression, right? For linear regression, this becomes the measure of error for it. Okay, that's why we'll be having something called the root mean square, right? The root mean square error. Okay, so basically that is all about this. And the subsequent classes, we're actually going to see how we will actually use the root mean square to check the error that we are actually making when we build algorithms, right? We're going to use this root mean square error to actually measure the error that we are actually having. Okay, so basically this is it for linear regression. I'll see you in the next class for logistic regression. Okay, have a nice day.